Hello everyone, and welcome back to the Fluctus Channel. The landing gear is a vital component of any aircraft, whether it's a helicopter, airplane, or space shuttle. Over the years, companies across the globe have experimented with sleds and other landing gear designs, but wheels have consistently proven to be the most reliable solution for safe landings time after time. Naturally, those wheels depend on tires to absorb the tremendous impact generated when an aircraft touches down. While aircraft tires may resemble modern car tires in certain respects, they are engineered to withstand far greater demands. They are built with significantly higher load-bearing capacity and enhanced resistance to the intense pressure variations encountered during high-altitude operations. Yet even with cutting-edge materials and refined engineering, aircraft tires can still experience failure on occasion. This C-17 Globemaster stands among the larger cargo aircraft operated by the United States military. With a maximum takeoff weight approaching 600,000 pounds and a length exceeding 170 feet, it is an imposing presence on any runway. To support the aircraft's remarkable mass during parking, takeoff, and landing, engineers designed 5 separate landing gear assemblies fitted with 14 individual tires. Each of these tires measures 40 inches in diameter and 16 inches in width. Replacing a flat or damaged tire requires a coordinated process and specialized tools. First, the landing gear is partially extended, and the affected strut is carefully lifted using a jack. This allows the worn or damaged tire to be removed safely. A replacement tire is then secured inside a wheeled sling, providing the maintenance crew with the leverage necessary to guide it smoothly onto the strut. In skilled hands, a well-trained team can complete this entire procedure in only a matter of minutes. Across the United States, military maintenance crews regularly test their tire-changing abilities in both formal competitions and informal challenges. These events are designed to sharpen skills while placing teams under intense time pressure. Sometimes, crew members are intentionally reassigned to unfamiliar teams to raise the level of difficulty. After all, in a real-world emergency, there is no guarantee that personnel will be working alongside teammates they know well. A sudden tire failure could require coordination with pilots or other individuals who are less experienced with the procedure. Performance in these challenges is judged not only on speed, but also on accuracy, as penalties are assessed for errors or procedural missteps. One of the cornerstones of aircraft maintenance is ensuring that the correct parts are always available when needed. This responsibility falls to aircraft parts store journeymen, who oversee verifying, cataloging, inspecting, and transporting supplies within the on-base warehouse. Their role demands an in-depth understanding of countless components and the specific aircraft each one supports. They must carefully manage ordering and stocking to prevent items from being misplaced within vast storage areas. When it comes to tires, every type must be clearly identified and positioned for rapid access. Weighing between 80 and 100 pounds each, even moving a single tire becomes a demanding task without proper equipment. Every aircraft is equipped with a landing gear configuration specifically engineered to match its mission profile, structural design, and operational requirements. Numerous factors influence this design, including total weight, center of gravity, runway limitations, wing positioning, fuselage shape, and the types of terrain from which the aircraft must operate. Fighter jets, for instance, emphasize compact and lightweight gear that retracts seamlessly to minimize drag. Regional airliners seek a balance between durability and efficiency to withstand frequent commercial operations. But when addressing a full-size strategic cargo aircraft like the C-5 Galaxy, the engineering demands expand to an entirely different magnitude. The C-5 Galaxy was conceived as a heavy intercontinental airlifter, capable of carrying oversized military equipment, armored vehicles, helicopters, and substantial troop formations across vast global distances. Stretching approximately 247 feet in length, with a wingspan surpassing 222 feet and a maximum takeoff weight nearing 840,000 pounds, it stands among the largest aircraft ever to enter operational service. Bearing such extraordinary mass during taxiing, rotation, touchdown impact, and braking requires a landing gear system of exceptional strength and carefully calculated distribution. To meet these requirements, the C-5 incorporates 5 landing gear assemblies and a total of 28 wheels. This multi-bogie arrangement disperses the aircraft's weight over a broad footprint, lowering ground pressure and enabling operations from runways that might otherwise struggle to support such a heavy airframe. Distributing the load across numerous wheels also improves braking efficiency and stability, particularly during crosswind landings or operations on uneven surfaces. Like any other landing gear system, the C-5 landing gear must be maintained with meticulous care. The aircraft's immense dimensions and weight impose tremendous stress on its gear structures, especially during takeoff and landing, when thousands of pounds of force travel through the struts, bogies, and braking assemblies. As a result, inspections are far more than simple visual walkarounds. They are structured maintenance procedures conducted in accordance with detailed technical orders and rigorous safety standards. A dedicated C-5 landing gear maintenance shop, operated by the 559th Aircraft Maintenance Squadron in Georgia, exists specifically to support this effort. Within this specialized facility, both newly manufactured and legacy components are received, dismantled, inspected, cleaned, calibrated, and rebuilt to precise specifications. Technicians service shock struts, torque links, actuators, wheel assemblies, and intricate hydraulic systems responsible for extension, retraction, steering, and braking functions. Every component is measured against strict tolerances to confirm it can endure the repeated stresses imposed by one of the largest aircraft in the United States Air Force inventory. The true wonder of modern aircraft is found not only in their visible power and performance, but also in the advanced engineering that quietly manages load distribution beneath the surface. At the center of this complex balance lies a component often overshadowed by more prominent innovations: the aircraft tire. The journey of aircraft tires began with modest origins, gradually evolving into the establishment of highly specialized and technologically advanced manufacturing facilities. Essential to every takeoff and landing, these components reflect a heritage of engineering precision and continual refinement. Charting a path from simple, early concepts to today's sophisticated, high-performance designs. The aircraft tire manufacturing industry is characterized by a clear oligopoly, dominated by four principal companies: Michelin, Goodyear, Dunlop Aircraft Tires, and Bridgestone. Together, they control approximately 85% of the global market share. This concentration, reported by Palmar Engineering in 2013, underscores the pivotal influence these manufacturers hold in driving tire innovation and reinforcing aviation safety standards. Exploring the broader world of aviation leaders, Safran Landing Systems stands out for its advanced landing gear solutions installed on modern aircraft. Safran is a major aerospace organization that designs, develops, and manufactures landing gear systems for a wide range of platforms. Previously known as Messier Bugatti Dowdy, this French company has grown to become the largest manufacturer in its field worldwide. Founded in 1995 as a joint venture, Safran Landing Systems has expanded through strategic mergers and acquisitions, ultimately becoming a key subsidiary of Safran SA. Operating internationally, the company's partnership with Michelin further strengthens the reliability and performance of its landing gear systems. Michelin presents itself as a respected and enduring name, with a rich history of producing high-quality tires for cars, buses, racing vehicles, and aircraft. Beyond civilian markets, Michelin also plays a significant role in military applications, demonstrating the adaptability and dependability of its tire technologies. The manufacturing process begins with rubber preparation, sourced from specialized suppliers, before being extruded onto tire frames. Despite the benefits of modern automation, much of the production process still relies on skilled manual craftsmanship, reflecting Michelin's dedication to maintaining superior standards. Layers of rubber are carefully applied over steel structures, shaped and processed until the exterior is finished with tread rubber. The critical bonding of the casing and outer tire, known as the crown, is achieved through inflation. This is followed by curing under elevated pressure and temperature conditions. Finally, the completed tire undergoes comprehensive quality inspections before being cleared for installation on an aircraft's landing gear, where its contribution to safety and operational performance becomes indispensable. Aircraft tires have a varied service life, typically lasting between 200 and 350 landings for nose tires and 350 to 400 landings for main gear tires. Because of this range, consistent inspection schedules are essential. When replacement becomes necessary, the aircraft is raised at the landing gear hardpoint using a hydraulic jack. Technicians then remove the worn tire and fit a new one in its place. The removed tire is sent back to the manufacturing facility, where its internal structure is carefully evaluated for damage. If no significant structural flaws are detected, the tire undergoes a detailed resoling procedure. This sustainable approach prepares the refurbished tire for return to active service, highlighting both the precision and environmental responsibility embedded within the aircraft tire maintenance cycle. From the smallest nose wheel to the enormous multi-bogie systems found on strategic airlifters, landing gear remains one of the most essential systems on any aircraft. It absorbs the immense forces generated at touchdown. Supports hundreds of thousands of pounds as aircraft traverse runways worldwide, and guarantees that every mission starts and concludes safely. Behind each smooth and uneventful landing stands a coordinated network of engineers, manufacturers, logisticians, and maintenance professionals working together with unwavering precision. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.